part system, right? Because if you think about it, and maybe to tie back to your question, Pat, about where does the supply chain come in, so how do we create these synthetic data sets? So if you have 1 million unique parts in a system, in order to compose, to kind of span the design space and create, a very large number of adjacent systems and some far away systems, you need a catalog of components, a catalog of component models, and some rules by which you can compose those components into systems. And your component catalog needs to be a couple orders of magnitude bigger than a typical system design.
Okay.
So if you have 1 million unique parts in a system, your component catalog maybe needs to be 100 million or a billion parts. And so you need to create that component catalog.
Okay.
Today we do it manually. We are building a lot of automation and a lot of actually AI tools to help us build that component catalog of component models. Then you have to intelligently assemble those components. So it's not a tornado going through a junkyard and assembling a 747, right? But you actually have some method for creating it. And then you have to simulate each of those and get a performance vector, right? That's the training data set. And so it's supply chain informed because in theory, all of the components in your catalog either reflect a real component in the supply chain, or you can introduce hypothetical components, right? Because sometimes innovation is not just assembling things that exist, but saying, hey, I need a new motor, or I need a new compressor, I need a new this, or I need new that, right? And so you can introduce new components that don't exist, but you know what those are and how you plan to get them.
Yes.
Right. So that's what we mean by supply chain informed, and physics based means that the rules of composing those components model all of the relevant modalities of interaction that you care about, the phenomenology of how they interact, and that the designs that are produced are in fact